Hi everyone, welcome to another session of GCSE Maths. So this should be our final session on algebraic expressions, and we're going to look at some exam questions. So here is an exam question, and it's from AQA November 2017. And this is our foundation tier paper number 1. Question number 31A. And it's a quadratic equation because x got power 2. So x squared minus 100, and it's only 1 mark. So what we have to do is we need to rewrite the equation first. We go x squared, so we just added the minus 0x minus 100. Now what we have to do is we have to find two numbers that have a product of 100 minus 100, or negative 100 I should say, and a sum of negative 0. So we're going to look at factors of 100, which would be 1 times 100, 2 times 50 would give me 100, 4 times 25 would give me 100, and 5 times 20, and 10 times 20. Now we need to look for two numbers that are going to give me a sum of, they're going to give me 100, product of minus 100, and a sum of minus 0. So only if we multiply 10 with 10, which will give me 100, and if we subtract from each other, we can get 0. So to factorize x squared minus 100, we can rewrite the equation x squared minus 0x minus 100, and now we need two sets of brackets. Then we write x on this one and then x on this one as well, and then now we write 10 here and then 10 there. So 10 times 10, that would be 100. We need negative 100, so that if we put plus here, then if we put minus there, so when you multiply plus with minus, that will be a negative number, which would be minus 100, which is this one. And then if we add plus 10 with minus 10, that will be 0, which means nothing. So that means our answer is correct. So to check whether our answer is correct or not, so if we multiply these two brackets together, then we should have x squared minus 100. So however, we have to be very quick because it's only 1 mark, so you don't have to write all these terms. So just you can show the answers, or can just work out the factors quickly. If we move to next question, which is a proof question, and this is question number 20 from same paper. It says n is an odd number. So remember, odd numbers are 1, 3, 5, 7, etc. And then p is a prime number. So prime numbers are only divisible by itself. So like 1, 3 and 5, 7, then 9 can't be a prime number because it's divisible by other number like 3. So question number A, 20A, it says show that n plus p is a square number, which means an odd number plus prime number is a square number. So we'll have to show that, and we'll have to write what are the values for n and p, so that they're going to give me a square number. So Values for n would be 1 and 9, and values for p would be 3 and 7. So we can prove that. If we put the value for n equals to 1 into this equation, and then p equals to 3, so that would be 1 plus 3 would be 4. Yes, which is this one. It should be the other way around, should be 1. It should be 1 plus 3. Yeah, it's not 3 plus 1, sorry. Should be 1 plus 3. So for value for n, which is this 1, and then value for p, which is this 3. So if we add them together, we'll have 4, which is a square of 2. Similarly, if we put value for n 9 and value for p 7, if we add them together, that will be 16, which is a 4 squared, which means adding odd number, which is n, and then prime number together, we'll have a square number. Yeah, there is a note here. It says prime number is only divisible by itself, so we'll have to remember that. So I think that's only just 2 marks, or 1 mark on this question. And part B, question number 20, part B, says NP is a square number, and then value would be 3, 5, 7, 11, 13, and value for P would be 3, 5, 7, 11, 13. Now we'll have to prove it. So if we put 3 times 3, which would be 9, so 9 is a square number. So odd number and multiplication of odd number and prime number is a square number. So 3 and 3, 9, which is 3 squared. We can work out 5 and 5 times 5, which would be 25, which is a 5 square. Same with 7 times 7, 11 times 11, 13 times 13, and so on and so forth. Okay, let's move to next question, which is from AQA November 2018, Foundation Tier Paper 1. It says, question number 23A, simplify n minus n plus 1, and it's only 1 mark. So we just take the bracket out. However, we'll have to multiply with this negative sign. So that will be n, and then that will be minus n. So if you take the bracket out, negative, and then negative number plus a positive number would be a negative number, and then negative times positive would be negative number. So that's n minus 1. Now we can cancel this n with this n, and we are left with only minus 1. Question number 23, part B. It says multiply out n and then bracket n plus 1. Again, it is only 1 mark for this one. So that would be n times n, which would be n squared, and then n times 1 would be just 1n. So this is our answer. Okay, so let's move to question number C, question 23C. The two numbers are added together, which is from this one, which is this one. Show that the answer must be an odd number. Again, this is a part of proof that we discussed in the earlier example. So what we need to do is we need to add these two numbers together. So here we go, n plus n plus 1. So these are the two numbers. And now we can compute this one. So that will be n plus n, which would be 2n plus 1. Now, as we know, 2 is an even number, so that would be even, and 1 is an odd number. So even plus odd would be an odd number. So it's like 2 plus 1, which is a 3. So that's a 3 is a odd number. 3 is an odd number. So next page. So I put all the rules for even and odd number. So you have to remember these. So if you know these rules for even and odd number, so if you go even plus even, that will be an even number. So it's like 2 plus 2 would be 4, which is an even number. Odd plus odd would be even number. So it's like 1 plus 1 plus 3 is 4, which is an even number. So if you remember this chart, then you should be able to answer these proof question. So that's it from me for today, and please subscribe for next video, and thank you for watching.